What's up? In this video, we're going to be talking about more on logarithmic functions. Hank wanted to come say hi, but he ran away. He's too scared. Until he's talking, he gets scared. All right. So in these first two, you're going to learn more about these as we move along. But I just wanted to show you because for whatever reason, Apex decided, hey, it's a good time to throw something at them that we've never shown them before, and we're not going to teach them. So these will be on the quiz. So I'm essentially showing you what is going to be on the quiz, and then we'll talk about it in the units to come. I just felt like it was unfair that it was on the quiz, so I'm just showing you guys how to do these as you come across them. All right, so simplify the exponential function. Here, I have a base of e to the ln of 3x. So here, when the bases are the same, e to the ln base e of 3x, this thing simplifies to just be 3x. Again, I'm sorry Apex does this to us, but I will show you how this works later on down the line. I think it's actually next video. Yeah, see, look at that. Next video. You're learning all the logarithmic properties. All right. Simplify the logarithmic function. So here's something, again, like I said, I'll go over this in the next video, is if we have multiplication, we can turn it into addition with the same logs. So with this, what this does is it becomes log of 10 to the 4th plus log of x to the 3rd. Then, again, if the bases are the same, just like here, 10 to the 10 to the 4th, all of this simplifies to just be 4. So it's 10 to the what power is 10 to the 4th? Well, that would be 4. So this would be 4 plus something else that we can do is we can move the exponent out front. So this would be 3 log of x. Again, you'll see these on your quiz. Let me know if you have any questions about them. We're going to talk about it in the very next video, or just go to the next video and be like, hey, how do you do those? And you'll see a lot more examples. You'll see these explained more in depth. So that's what the next video is all about. All right, what do we really get into, though? If the camera will work, there we go, is graph the following and state the equation of the vertical asymptote. So we learned in the last video about graphing logarithms. Remember, if the base is 1, sorry, not if the base, if the base is greater than 1, it's going to be increasing. If the base is less than 1, it's going to be decreasing the entire time. It'll be growth or decay. So here, remember, if I don't see a base, it's assumed to be 10. So now what's going to happen is this going to move my log to the right 3 and up 2. So remember, there's vertical asymptote at 0. So if I move that vertical asymptote right 3 units, it's now at 3. And also remember, logarithmic functions have a x-intercept at 1, 0 every time. So if I take that and move it up 2, so up 1, 2, it'll hit right there. So I will get closer to my asymptote, and then once I hit my x-intercept, that's when I start to show my outward growth. That's it. So now, stating the equation of the vertical asymptote, notice it's going up and down at 3 because it moved right 3, so my vertical asymptote would be at x equals 3. That's it. That's all we're asking for. All right, with part B here, notice it says natural log, but natural log, remember, has a base of e. Also remember, e is approximately 2.7182, so approximately 2.718. So all that means is it's going to be increasing as well. So we'll have, again, a parent function that crosses at 1 that is increasing as it goes. So this plus 4 is going to move it to the left 4. This minus 3 is going to move it down 3 units. So left 1, 2, 3, 4. So I'll have my vertical asymptote now at -4. So I'm going to go ahead and say x equals -4 for the vertical asymptote. And then I will be down 3 units, so down 1, 2, 3, to get where the x-intercept kind of moved to, from my parent function at least. And then I will have an increasing growth logarithmic function as it goes. All right. Next, we have graph. Given the function f of x, find the inverse and graph the inverse. So remember, for the graphing of the inverse, let's see, this one moves to the right 1, and it moves up 2. So if I take that and I move it right 1, up 2, my x-intercept from here, right 1, up 2, will be something like this in blue. So now if they reflect over the line y equals x, that line is right about there. So if it reflects over this line, remember all the x values become the y's, what's going to happen is since they hit right on that line, it'll hit right there as well. And as it goes away, notice it goes towards there, so this will go right there. And then it's going to kind of go like that. So that if I were to look at specifically this line, you can see it reflects right on that line. All right, give me just 1 second. All right, and then we could actually find the inverse. Remember, just switch the x and y and then resolve for y again. So if I switch the x and y exactly where they are, that would give me x equals log y minus 1 plus 2. So now, this is weird with logs, so we got to think about this. First thing I would do is get the log by itself. So subtract that to the other side so that we have x minus 2 equals log of y minus 1. So now, I'm kind of stuck in log form. So remember, when I'm stuck in log form, I'm going to rewrite in exponential form. So the way I do that is I have a base of 10 here. So I'm going to do 10 to the other side. So here, I'll write this down over here. So 10 to the x minus 2 equals the thing inside the log, which was y minus 1. Add the 1 to the other side. So I have 10 to the x minus 2 plus 1 equals y. There's my inverse function. So I have 10 to the x minus 2, so 10 to the x, which is an exponential function that is growing, has been moved right 2, up 1. So we can see it moved right 2, up 1. There was my intercept, and it's getting closer and closer as it goes out forever. Cool. There it is. Whoop. There it is. All right, determine the x-intercept of the function. So what we just talked about is going to help us determine the x-intercepts of these as well, that solving portion. So remember, an x-intercept is when the x value, and I know the y value is 0. So for any x value, the y value has to be 0. So since the y has to be 0, I can put in a 0 for y and keep the rest of the equation the same. So now I'm going to actually solve for it. So what I would do, again, get the log by itself. So I'd add 2 to both sides. So 2 equals log of x plus 1. Remember, for a log, whenever you don't see the base is understood to be 10. So now if I'm stuck in log form, I'm going to rewrite in exponential form. So I have 10 to the second equals x plus 1. 10 to the second is 100. So 100 equals x plus 1. So if I subtract that 1, then I get x equals 99. So my x-intercept then would be 99, 0. Yeah. Here, again, the x-intercept, the y value is going to be 0. So 0 equals 3 log of x plus 6. I would subtract that 6 to the other side first. So minus the 6. So negative 6 equals 3 log of x. Then I can divide by that 3 since that 3 is outside my log. So divided by 3 on both sides. So I have negative 2 equals log of x. Again, log base 10 if you do not see the base. So what this is then is 10 to the negative 2 equals x. Remember, negative exponents can be rewritten. So x equals 1 over 10 to the second, which is x equals 1 over 100. So my x-intercept would be 1 over 100, 0. That's it. All right, moving on. These ones, they're actually going to ask you to solve for x. So we're going to talk about more of this in the next video as well. Not necessarily the next one it looks like. It looks like it's 310. You get to solving log equations. And these are actually all exponential, so in 3.9 we'll get to solving exponential equations. All right, but here's a quick trick. So solving for exponentials, my x is in my variable, or exponent. So if I divide by 200, so I'm wanting to get the x by itself, then I will have 4,000 divided by 200 is 50. I believe, no it's not, it's 20. What am I talking about? Crazy man. E to the 4x. So now I'm stuck in exponential form. Notice my base is e, so what I'm going to do is rewrite this as a natural log, so the base is e, of 20 equals 4x. So now to get that x by itself, I can divide both sides by 4, so x equals ln of 20 over 4. So now, and later on, we'll actually estimate what this value is, but for now, just leave that ln of 20 over 4. That's probably how you're going to see your answer. Moving on with part B. Again, solve for x. So what I would do first is divide by 100 on both sides. So I have 3 equals 2 to the 4x. Now I'm stuck in exponential form because I have an x in my exponent. So I'm going to rewrite this in logarithmic form. So I have a log with a base of 2 of 3 equals 4x. Then divide both sides by 4. So I have x equals log base 2 of 3 divided by 4. There's our solution. All right, moving on. 100 equals 40 times 1.404 to the x. So again, divide by the number up front, divide by 40. You cannot ever divide by the base. Do not ever divide by the base. It's not possible. Do not ever divide by the base. We can multiply by the number, or divide by the number out front though. That is possible. So if I divide by 40, I have 10 over 40, 10 over 4, so 5 over 2 equals 1.04 to the x. So now the only thing I have left to do here is rewrite it in logarithmic form. My base is 1.04 of 5 halves equals x. So there it would be solving. Again, they're going to leave it like that for now. We'll get into the actual decimal values of that in just a little bit. All right, that's all I got for you guys today. Please let me know what questions I can answer for you. I'll talk to y'all soon. Bring it on.